Hello everyone. In today's video, we are talking about how to complete the perfect square. So, first of all, what does completing the square do for us? Number one, the result is going to be called vertex form. And this is basically changing from your standard form to a form that is easier for us to graph and potentially do some calculations. So first of all, what does vertex form look like? It will look like this. Y is equal to a bracket x minus p, close bracket squared plus q. Your vertex will be located at p comma q. Now please do keep in mind that the x coordinate, the p value, will be the opposite of what you see, and the q value is exactly what you see. So we'll take a look at some examples later, so be aware of this one specific detail. What is standard form? Standard form is commonly known as y is equal to ax squared plus bx plus c. So again, always be aware where is your a, b, c values. Now let's take a look at the steps that we need to take in order to complete the square. So step number one, factor the a value from the x squared and x term if the a value is not 1. If the a value is 1, then you don't need to worry about this first step. You can just go into step number 2. Step number 2 says we're now going to take half of the b value. Again, the b value was in front of the x variable. Okay? And then we're going to square after we take half of the b value. So once again, you're going to take half of the b value and then square it. You're going to then add that number behind x. Now, because we added this number that didn't exist before, we need to create a balancer. So by doing that, we subtract that value. So for example, let's say I took half of the b value and I squared it, so then I added some 36. So then I need to minus 36. So that minus 36 acts like a balancer. Now, once we have a balancer, we need to take it out so that we can actually figure out how to complete the square. So step number 3, take out the balancer and check if your a value, if it wasn't 1, well, you need to multiply it in order to get that balancer out of that position. And then lastly, once the balancer is outside, then you can complete the square and simplify the constant. So let's run through some examples to see what happens when a is 1 versus when a is not 1. So here's our first example. Complete the square. You can see here that our a value is 1. So we will write out each of the values. A is 1, b is equal to 6, and c is equal to negative 5. So again, we take a look here. A is 1, so we can skip directly to step number 2. And step number 2 says we're going to take half of the b value, in this case 6. So half of 6 is 3. And then we're going to square it. So 3 squared is going to be 9. So we're going to write x squared plus 6x plus 9. Okay? And then I need to add in the balancer. So where that plus 9 came in shouldn't exist. So we minus a 9. So that is the balancer. And then we just keep the value of c in the back of minus 5. Here's where the perfect square comes into play. The front 3 terms is actually a perfect square. So if you guys have factored before, then you understand that in order to complete the square, this front part here is the same as x plus 3 all squared. Now you can expand this, FOIL it out, and then you'll come back to this x squared plus 6x plus 9. So in this situation here, this is the front piece, and then the back piece, minus 9 minus 15, that gives us minus 14. So we have now completed the perfect square. Now a lot of students struggle with the front part. Again, the front trinomial here that we factored into a perfect square, you can also simply think about it as I reduce the x squared down to an x, and then I take half of the b value, and then I close the bracket and I put a square on top. There you go. So this one here, once we have completed the perfect square, we can then say that the vertex is located at, in this situation, negative 3 comma negative 14. Remember, the p value, right, is the opposite of what you see in those brackets. So it was x plus 3, so p has to be negative 3. And then whatever just on the outside, that's your q value, and therefore it's just negative 14. Now let's take an example when the a value is no longer 1. So we see here that a has a value of 3, b has a value of negative 12, and c has a value of 10. So in this situation, since a is not 1, we do need to factor out the a value from the x squared term and the x term, which means the front two terms. So let's factor out 3 from the front two terms first. So now we have x squared minus 4x, and we keep the plus 10 on the outside. So now we can take a look at what's inside the brackets. We see here that x squared has a leading coefficient of 1 now, so we can just continue with step number 2, where it says you take half of the b value and square it. So for this one here, we'll have the following. So the b value here is -4. Divide that by 2, you get -2. In brackets, you square it, and you get +4. So here, because I did +4, that 4 didn't exist in the previous equation, I need to add in the balancer, which would just be a -4. We keep the +10 since we never used it. Now I need to take out the balancer, right? The balancer is this number here, the -4. In order to do that, it gets affected by the front value a, that 3. So here, if I were to take it out, first write down what's left inside. When I take out the -4, it gets multiplied by the 3. So then actually -12 comes out. So I can go +10 minus 12. Now I can complete the perfect square. So for this one here, we see that for this trinomial, I can just drop the power of 2. So we get x, and then we take half of the b value, which in this case would be -2, close it, put the square on top. And again, you can expand this if you want to double check that it comes back to the previous step. And the back piece here is just +10 minus 12, giving us -2. So here, the vertex would be located at 2, -2. Again, a reminder that the p-value is the opposite of what you see, and the q-value is exactly what you see. So I hope this has helped you figure out how to complete the perfect square. That's it for today's video. Make sure to like the video and subscribe to the channel. It would mean so much to me. Thank you so much for watching, and I'll see you in the next one.